Hello, I am Khaja asifullah from Government Degree College, Palakuma, Hyderabad. Hello, I'm Khaja asifullah from Government Degree College, Palakuma, Hyderabad. Today, we will discuss about solutions. Actually, this is part 2 or second lesson of the solution. In part 1 or first lesson, we discussed different things in solutions. One important thing which we discussed was about the concentration and the ways to express the concentration. Today, let us recall that solution is nothing but a homogeneous mixture of two or more substances. Next one, as I told you in the earlier class, that in a solution, there may be one or more than one solutes. Why? Because solute plus solvent gives you solution. If there is only one solute along with solvent in solution, it is called a binary solution. In this type of solution, there are two components. One component is solute, the other is solvent, but here only one solute is there. For example, if you dissolve sugar in water, it is a binary solution, or sodium chloride in water, or alcohol in water, etc. As I told you earlier in the last lesson, that we can have types of solution and there are different ways to categorize that. One of the way to divide the solutions into different types is on the basis of amount of solute present in the solvent. Okay? That type is called saturated solution, unsaturated solution, supersaturated solution, etc. Today, we will discuss about the types of solution when we consider the physical state of solute and solvent. And you know that matter exists in three different physical states or forms: solid, liquid, and gas. Because in a solution, there are two components, solute and solvent. Both may exist in three states, three different states. Therefore, totally we will have 3 into 3, 9 types of solutions. One of the 9 solutions is gas in gas. Means here, solute is gas, solvent is also gas. Like air. Air is a mixture of many gases like nitrogen, oxygen, carbon dioxide, etc. Next type of solution is liquid in gas. Again, we can take example as air. Why? Because in air we have water droplets or vapors of water. It is sometimes called as moisture. The third one is solid in gas. Again, air we can consider as an example in which dust particles are present. Similarly, smoke. In smoke, solid particles are there in air. For example, if we take smoke, it may contain carbon or sulphur, etc. as solid particles. Fourth one is gas in liquid. Now we have solvent as liquid, whereas solute again has three different forms: gas, liquid, and solid. Gas in liquid like soda water, which is formed by the solution or dissolution of carbon dioxide in water. Next is liquid in liquid, like alcohol in water. Sixth one is solid in liquid. This is the most common example: sugar in water, or sugar solution, or aqueous solution of sugar. Next is gas in solid. Here, next three example types, we have solvent as solid, whereas solute is again either gas or liquid or solid. Gas in liquid, like hydrogen gas in palladium metal, or H2 in PT, that is platinum. Liquid in solid, like Hg and a metal or jellies. Last one is solid in solid, like alloys, brass, bronze, etc., steel, many are there. These are nothing but a type of solution in which solid is dissolved in solid. For example, in brass, zinc and copper are present in solid forms. They are melted together, then stirred well, and then they are allowed to settle down, then cooled. Out of these 9, 3 are of importance for us. These are gas in liquid, liquid in liquid, and solid in liquid. Gas in liquid is again soda water or any other gas present in water. And liquid in liquid like alcohol in water. Solid in liquid like sugar solution, etc. But here we will first take the first one, that is gas in liquid. For example, carbon dioxide is dissolved in water. It is nothing but soda water. As you know, most of the gases dissolve in water and other liquids to a certain extent. Whenever we try to dissolve any gas by passing through it through a liquid solvent, then naturally it gets dissolved in it up to certain extent. Few may dissolve in more amount or quantity, few may dissolve in less amount or quantity. We know that gases like oxygen, sulfur dioxide, carbon dioxide, etc. dissolve in large amount in water if it is present in as a solvent. Now, we consider the solubility of a gas in a liquid. On what factors it depends? The factors on which solubility of a gas in a liquid. First, temperature. Second, pressure. Third, nature of solvent and solute, etc. First of all, let us deal with the effect of temperature. Let us try to understand what effect temperature has on solubility of a gas in a liquid. It is observed that solubility of a gas in a liquid depends on temperature, and solubility of a gas in a liquid decreases with increase in temperature. Means when temperature is increased, the solubility of gas decreases. Why? Because its boiling point is low. As a result, it gets evaporated from that solution in which it was present. Hence, at low temperature, more gas is dissolved. This is the reason why soda water and any other soft drink are kept under cold conditions. Second is the concentration, effect of concentration and the solubility of solute present in a gaseous form. Solubility of a gas in liquid depends on concentration. As concentration increases, solubility decreases. Again, reverse is the case. It is inversely proportional. If concentration is high, solubility is less. If concentration is low, solubility will be more. Third one is nature of solute and solvent. We know that nature here means either it is polar or non-polar. Why? Because when they get dissolved in water, water is a polar solvent. Therefore, polar gases may dissolve easily in water, whereas non-polar gases get dissolved in non-polar solvents like benzene, etc. So, and nature of solute and nature of solvent solubility depends. The last one is effect of pressure. It is most important factor for us because we have to deal it in detail. Pressure also affects the solubility of a gas in liquid. At high pressure, more and more gas will dissolve, whereas at low pressure, solubility of a gas is low. This is the reason why soda water and other soft drinks are kept under airtight conditions. Why? Because these gases are allowed to dissolve in liquid like water, etc. at high pressure. If these are kept in open vessel, then what happens? The gas will evaporate. It will enter into air and slowly the liquid or solvent will remain. As a result, we have to keep them in airtight or sealed bottles or vessels. If these are kept in open vessel, the gas will evaporate, leaving behind the solvent. Only solvent will remain, whereas solute will evaporate. Now we take solutions of gas in liquid and we try to understand Henry's law. What is Henry's law? Why we are trying to understand? Most of the gases dissolve in water and other liquids up to a certain extent. And we know that the solubility of gas depends on pressure. This was studied for different conditions and in taking different gases by Henry. Now, what we try to understand. First, consider absorption coefficient, what it is. Solubility of a gas in a liquid is generally expressed in terms of absorption coefficient, and it is represented by alpha, which is defined as the volume of gas at NTP dissolved by a unit volume of the solvent. What is the meaning of NTP? NTP or STP are the conditions of temperature and pressure. N stands for normal, T temperature, P pressure, R, S for standard temperature and pressure. So what are these in normal or standard temperature and pressure? It is 25 degrees centigrade temperature or 298 K, and pressure is 1 atmospheric pressure. So the volume of gas, how much volume of gas is dissolved in unit volume of the solvent. Let us consider it as 1 liter of the solvent at normal temperature and pressure. This is called absorption coefficient and is denoted by alpha. Now, the effect of pressure on the solubility of a gas in various liquids was studied at large by Henry. The result was generalized in the form of a law, which is called as Henry's law. It is stated as follows. The mass of gas dissolved in a given amount of liquid at constant temperature is directly proportional to the pressure of the gas in equilibrium with the liquid. It is mathematically given as M proportional to P, or when we make it as an equation, M is equal to Kp, which gives us as K is equal to M by P. Actually, as we listen just now, that when pressure is increased, solubility increases. So here we are taking certain amount of liquid in which we are trying to dissolve certain mass of gas. So the mass of a gas dissolved in a given amount of liquid at constant temperature means we are keeping the temperature constant. Then the mass of gas dissolved in unit volume of the solvent is directly proportional to the pressure. Now the gas and liquid should be in equilibrium. Means the gas should be above the surface of the liquid in a closed container or vessel, and the gas should be kept at high pressure. Now we have to convert it in mathematical expression because it is direct proportionality, so M proportional to P, and the equation we get M is equal to Kp. Now what M, P and K are here? Here M is mass of the gas which is dissolved, P is pressure of the gas to which it is subjected, and K is a constant. This constant is called Henry's constant. Okay, and it is characteristic of the nature of the gas, nature of the solvent, and temperature. So the value of K for a particular gas depends on the nature of solute and solvent, and next to it is temperature. Now, certain limitations are there for Henry's law. What are the limitations? First of all, this law holds good only to a gas which is least soluble, or solubility is very, very less. Second is the gas should behave like an ideal gas, means at low pressure and at high temperature. And third is the molecules of gas should neither undergo association nor dissociation, and it should not react with the liquid or solvent. We know that many gases are there which dissolve in liquid like water, but on dissolution they get dissociated, or sometimes they associate with the molecules of liquid like water. For example, if I dissolve HCl in water, you know that HCl will produce H plus and Cl minus ions, means it is dissociating. Similarly, in H3, there is ammonia, produce NH4 plus ions and Cl minus ions. So there is a reaction sometimes, there is association sometimes, there is dissociation sometimes when certain solutes in the form of gases dissolve in solvent like water. So there, this law will not hold good. Okay. Then, if we consider these solutes like HCl and NH3 in benzene, you know, in benzene these are slightly soluble. So this law, Henry's law, holds good when solute is slightly soluble. Here, instead of water, if we take benzene as solvent, then the law will hold good for HCl and NH3. Why? First of all, they are slightly soluble in benzene. Second is they do not react with benzene, that is solvent, and they do not undergo either dissociation or association in the solvent. Therefore, this law holds good. Today, let us stop here. In the next class, we will take next type of solution, which is nothing but solid in liquids, and we will try to understand Raoult's law. So for today, it is